All right, class. So we can get started here. This is your exam number 12 from last time. So, let's look at number 1. So in 2010, U.S. households held an average of $7,768 in credit card debt. 5 years later, in 2015, this number was $7,327. Assuming that this change is linear, find and interpret the slope. So when they say the change is linear, that means from year to year, the change in credit card debt is the same amount. Okay, so to find and interpret the slope, all right, remember the slope is your change in y value over the change in the x value, all right, also known as triangle y, triangle x, or rise over run. Okay, so in this case, the input, your x, would be time. All right, as time passes, in this case, we're looking at a 5-year change in time. How does the credit card debt change? So the top is the output. So the change in y would be the change in the debt. And the change in x would be the change in the time. All right. So the change in debt, we're going from 7,768 to 7,327. So the debt, the amount of debt is decreasing. Okay. So that means our slope will be negative because we're going downhill. All right. So we have 7,327 minus 7,768. All right. So the debt was 7,327 in the year 2015. That's at time 5. We're going to consider 2010 to be time 0. Okay. So we have time and we have debt. All right. Those are our two variables. All right. The time is the independent variable. The debt is the dependent variable. The amount of debt that they have depends on the year. Okay. So we're just doing change in time, change in debt. Okay. So if we use our calculator, let's see here, calculator. 7,327 minus 7,768. So what we have is the debt has gone down $441 in 5 years. Okay. So $441 in 5 years is basically $88.2 per year. All right. So 2010 is going to be time 0. 2015 is time 5. So the difference, the change in the debt has been $441 over the 5 years. So the slope, the rate, if you simply put that in your calculator, you're losing $88.2 in debt every year, assuming that this change is linear. That's what they mean by linear. They mean every year the debt changes by the same amount. That's what gives you a straight line. If it wasn't a straight line, if you had something curved, that means, in these years, the slope, the debt changed a little bit, but over here in these years, the debt changed a lot. But we're assuming linear. So all we need is the change in the debt compared to the change in time, again, which is negative $88.2. It's negative because it's decreasing. It went from 7,768 to 7,327. So on average, that's $88.2 per year. So now that we know the slope, And they want us to interpret the slope. So this would be change in debt per year. So they want us to write a function modeling debt in terms of X years, starting in 2010. So our debt, where X is time in years. All right, you remember your Y equals MX plus B. Here's our M. All we need to know is what B is, our y-intercept. It says in 2010, that's time 0. The debt was 7,768. Okay, so what we have here is negative 88.2 x plus 7,768. So that's our function. If you plug in a 0 for time 0 is 2010, the year 2010. Okay, and in 2010, we had debt of 768. After that, as each year increases, if as 1 year passes, the debt goes down $88.20. So after 5 years, all right, the debt would decrease by $441, which would leave us at 7,327. All right, so that's our function. We just need to find the slope and then the y-intercept. And the y-intercept is what you get at time 0, or when x is 0. Remember when you graph your b, that letter b, boom, 0b, it's the value you get when your input is 0. Okay. So now that we have the function, they want us to predict the credit card debt in 2035. So in 2035, if 2010 is time 0, 2035 would be at time 25 years later. So we just plug in 25 into our function. All right, because again, at time 0, we had this much debt. But every year, we lose $88.2 in debt. So after 25 years, we need to subtract that much from our original amount. And let's see what we get. 88.2 times 25, make it negative, and take that away from 7,768. That puts us at $5,563 dollars. So again, that's after losing $88.2 of debt per year. We found that by looking at a 5-year interval, this difference over 5 years. That's it for number 1. Now for number 2, out of all the mixture problems, this is going to be the hardest one. All the other mixture problems y'all have gotten, they'll give you 2 out of 3 of the volumes, and then you can easily find the third one, right? And then you plug in that third one down here, and then there's like a concentration that you solve. This one's a little different. Okay, this one requires substitution. All right, so we have 7 gallons. So V1 is 7, and it's a 4% acid. So C1 is 4. And it's mixed with some 1% acid, and it says some, it doesn't tell you how much. So we don't know what V2 is, but its concentration is 1. And that will produce a 2% acid solution. They say a acid solution. They don't tell you how much acid solution, but they do tell you its concentration is 2%. So how much 1% acid is required? That's your V2. And how many gallons of 2%? That's your V3. So what we need to find is V2 and V3. All right. If we look and plug these numbers into our basic equations here, V1 is 7 gallons, all right? And then V2 is unknown, and V3 is unknown, all right? If we plug in our numbers into this equation, see we have 7 for V1. Our concentration one is 4%. You can do this two different ways. You can either leave the percentages in there, percentage symbol like that. It'll eventually cancel out. Or you can use 0.04 for 4%. Okay. So we'll go ahead and just do 0.04. Nah, let's just put 4. All right, I'm just gonna put 4. And it's assumed that we have percentages in there, okay? Because if there's percentages here, and percentages here, you can just divide out that percentage symbol across the board, okay? So V2 is unknown, but C2 is 1%. V3 is unknown, but C3 is 2%, okay? So what we're looking at here, 7 times 4 is 28. 1 V2 is just V2. And then we have 2 V3. So we have this equation and this equation. All right. There's 2 equations here and there's 2 unknowns. This one has 2 unknowns. This one has 2 unknowns. So you can't really solve for one of them, right? But what you can do is you could substitute. If V3 is 7 plus V2 and we plug that in here, if we rewrite this equation by substituting that in, check this out. Replace V3 with 7 plus V2. This equation only has 1 unknown now, and we can solve for V2. That's the trick. Whenever you have 2 unknowns, you have to have 2 independent equations. And then you can solve for both variables. You just have to substitute one equation into the other. All right. So what we did is we got rid of V3. We rewrote it in terms of V2. And so now all I have is V2s. And I can solve for V2 now. All right. If I multiply this out over here, 2 times 7 is 14. And we have 2V2. If I subtract 14 from both sides, I get 14. And I'll subtract V2 from both sides. 2V2 minus 1V2 is just V2. All right. So I saw one of the variables. Now that I know V1, I know V2, I can find V3. I just plug this back in here. Okay. So V3 is 7 plus V2. And we know that V2 is 14 now. So V3 is 21. So again, this whole problem hinges upon substituting one equation into the other equation. When you look at this, you see you have 2 variables. You look at the other equation and see if you can rewrite one of the variables in terms of the other one, so that you can make an equation that only has 1 variable in it instead of 2. Any questions? All right. Now, what do y'all think about Calabria Road? It sucks, doesn't it? My God, it took me like 55 minutes to get here. You know, the map says 30, you know, because all those stupid trucks and lousy drivers. There's that quarry that's out there. It's a big quarry out there. There's just huge trucks just full of stuff. Like every other car is a giant truck driving so slow. And then they want to do trash pickup in the middle of it. You know, so there's this truck driving 10 miles an hour picking up trash. And then all those schools, you got all those schools. Last week I tried to get out of here and get home, and I drove past 3 car wrecks, all within like a mile. I guess it's all those kids going to high school, none of them know how to drive without, you know, trying to check out the chicks on the sidewalks or something. What is this, number 13? Quiz number 13? This was exam 12. Yeah, we have quiz number 13. Before I forget, I had better make the little place where you can upload your answers. Okay, let's see. UIZ number 13 is worth 100 points. It's a quiz. I'm gonna do a file upload. Let's do the second. Save and publish. Do the exam. Come on, internet. Exam number 13. Exam. Boom. Come on. Where did we leave off last time? Page 99. Okay. Come on, computer. There we go. All right, that's where we left off. So let's pick out some problems from our and I need a new computer. This one's so slow. There we go. Applications. So we've done that one. We've done that one. We did that one. Let's try. There we go. Let's do some graphing here. Quiz number 13, use the slope intercept method to graph the following lines. Let's see if I can remember which ones we did last time. We do this one last time, number 14. I'm not sure, it won't hurt us to do it again. snapshot. You can graph them both from this one map here. Okay. Let's see, we should be able to do this in 10 minutes. We'll do 12 minutes, how about that? So we'll assume it's 10:55 and then 10 minutes, so 11:05. 11:05, I'll work these for you. In the meantime, y'all can work together. However y'all want to approach this. All right, class, let's look at quiz 13 here. Number 1, so they want us to use specifically the slope intercept method. So the first step is to put it into slope intercept form. So if we take this guy and we want to get it in y equals mx plus b form. So let's subtract a half an x from both sides. So if we do that, we will end up with this. You know what? Let's just get rid of the fractions first. Screw these fractions. Let's multiply everything by a 6. And that will give us a 3x minus 4y equals 15. Now we'll subtract 3x from both sides. And now we can divide everything by a -4. So now we have it in y equals mx plus b form. Our b here is -15/4. So see, what is that? 15/4. So it'd be like 4 goes into 5, see 12. That'd be 3 3/4. Is that right? 15/4. 3 and 3 would be 12/4, and then another 3/4. So -3 and 3/4. So we go down 3 3/4. Right about there. Our slope is 3/4. So for every 3 we go up, we have to go 4 to the right. So if I go up 3, 1, 2, 3, and then go to the right 4. 1, 2, 3, 4. That puts us right here. Okay. So that point, let's see. See, this point is 0 and -15/4. So let's see, if we've gone to the right 4, it'll put us at 4, and we've gone up 4. We've gone up 3. 3 would be 12/4. We're at 15/4, so that put us at -3/4. And then we got a line. Let's see, I'll do that one in blue. Now let's look at number 2. Everybody follow number 1. It kind of sucks because it has fractions in it, right? It'd been nice if this number would have been a whole number. Come again?
Like we have 1 over 2, 2, 5 over 2. These come down to 6, but you don't change those to 6.
I just multiplied both sides of the equation by the number 6.
So you don't change each other.
Well, 6 times a half is 3.
Yeah.
Right? We're not trying to get a. Yeah, we're just getting rid of the fractions. We're not trying to add these fractions together. Right? I don't need to add this to this. We can't add those together because one has an x, the other one has a y. So I can't add those together, right? 2x plus 3x, yeah, is a 5x. But if I had 2x plus 3y, I have to just leave that. I can't add those together because it's different variables. You see what I mean? So the purpose of multiplying by the 6 wasn't to be able to add these fractions together. It was simply to get rid of the fractions. Yeah. Now, in the end, the fractions came back, and that sucks, but, you know, Sometimes it works out, sometimes it doesn't. So for number 2 here, there isn't even an X here. That's okay, right? If I divide everything by a -6, I get Y equals -2. Okay. If you want to think about it as Y equals mx plus b form, this would be 0x minus 2, right? Our slope is 0. Our b is a -2. Okay, so I'll do this one in green. All right, y equals -2. That's the line where all y values are at -2. That would be this line right here. All right, notice the slope is 0. It's not going up, it's not going down. All right, b equals -2. Boom, that's that point right there. That's 0, -2. Okay. So this one you can follow the same method as you would any other where the m is not 0. It's just the slope here happens to be 0. So this is the line where all y values are -2. And that's it for quiz number 13. Any questions? All right. Let's look at. All right, so last time we graphed x squared, okay? And we graphed x squared simply by plugging numbers in and getting the numbers back. -3 squared is 9, -2 squared is 4. Got a 1, 0, 1, 4, 9. So when we graphed this last time, yeah, page 99. So we found that this is what x squared looked like when we graphed it. We found that the right side looks exactly like the left side. That's because if you square a negative number, you get a positive number. So these numbers are the same as these numbers, okay? It means the stuff on the left looks like the stuff on the right. So this is your most simplest quadratic, x squared. Remember, a quadratic looks like this: ax squared plus bx plus c, okay? So the highest power is x squared, all right? This is the simplest one because for x squared, that means that a is 1 and b and c are both 0, okay? But from this x squared, the graph of x squared, we're going to figure out how to graph all the quadratics, anything that's of this form. So we want to be able to graph 2x squared plus 3x plus 1. We want to be able to graph 9x squared minus 2. All right. So we want to be able to see what do these a, b's, and c's do to the basic x squared, okay? And last time we learned about the vertex formula. It was -b/2a. So if you have a quadratic of this form, -b/2a is going to be important. Has something to do with the vertex. The vertex would be this point right here. It's at the bottom of the valley, or if this thing's upside down, it's at the top of the hill. So this one is x squared minus 4. All right, well, guess what? If this is x squared, all right, this is x squared. What if we want x squared minus 4? Well, remember, how far you go up or down is the output. So what we're doing is we're taking 4 away from the output of x squared. If you subtract 4 from your output, all you're going to do is move this down 4 units. That's what it's gonna look like. And we can see that if we just do the plug and play, by inserting numbers and seeing what comes out. Let's see, if we take -3 and square it, we get 9 minus 4 would be 5. Write that 5 again. -2 squared is 4 minus 4 is 0. -1 squared is 1 minus 3 is a -3. 0 squared minus 4. 1 squared is 1 minus 4. We got 0, and 9 minus 4 is 5. So we look at this, we go -3, we have to go up 5, -2, 0, -1, down 3, 0, -4. All right, so by doing the plug and play, we can see it's exactly what we thought it was going to be. It's going to look exactly like x squared, but moved down by 4 units because that's what we did. Okay. Page 101. All right, a quadratic function, like I said, is of the form f of x equals ax squared plus bx plus c, where a is not 0. If a was 0, you'd have a line, a straight line, y equals mx plus b. Here they call it bx plus c, but it's still linear. All right, this is called a parabola, this shape that you get from a quadratic. So they want us to label the vertex, the axis of symmetry, the y-intercept, x-intercepts, and max or min. Okay, so for the first one here, here's our vertex. The vertex is 0, -2. Okay, the axis of symmetry is this line right down the middle. It's called the axis of symmetry because you can fold the graph over that line. So that line right there is x equals 0. It goes all the way up, all the way down. It takes on all possible y values, but then the equation for that line is x equals 0. Every point on that line has an x value of 0. All right, the y-intercept, well, that's the same as the vertex in this case. Right there, that's where it crosses the y-axis. The x-intercepts are going to be here and here. This would be what? 1.5, 0. This is like -1.5, 0. Those are the x-intercepts where it crosses the x-axis. The maximum or the minimum. All right. The maximum, this thing goes all the way up to infinity. So the maximum is infinity. The minimum value it takes is down here at -2. So the lowest it goes is -2. The highest it goes is infinity. So when we're talking about max or min, we're talking about the output, which is how far up or down it goes. So for this one here, let's see, the vertex would be this point, which is 5, 9. That's the vertex. Okay. The axis of symmetry is right here, and this line is at x equals 5. Notice the axis of symmetry goes through the vertex, right? So that number right there, that x value is always going to give you your axis of symmetry. Okay. So y-intercept, we can't see where the y-intercept is, but I guarantee you there is one down here somewhere. It's just off the graph here. So there is one. Because if you kept going down forever, notice this thing is going to the left a little bit all the time, right? So if you went down forever, this thing would eventually go forever to the left. And you just kept going down, 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 down. It keeps going to the left, going to the left. Eventually, it's going to be infinitely far to the left and infinitely far down. Okay. So our x-intercepts are here and here. This would be what? 8, 0, and 2, 0. Now the maximum, the min, all right, the highest this thing gets is to 9. Okay. I'll put that there, 9. The minimum is negative infinity. It goes forever downwards. So there's just the main properties of parabolas. Okay. All right. When they say opens up or opens down, this one opens upwards. This one opens downwards. Okay. And the way you can tell if it's going to open upwards or downwards, if A is positive or if A is negative. Okay. So the A is the number that you're multiplying your x squared by. And that's what tells us. Remember, x squared, just x squared looked like this. It opened upwards. That's because A is 1, which is positive. Okay. The axis of symmetry, it turns out that the axis of symmetry, this x value, all right, where this line is, I already told you it's the same as the x value from the vertex, right? Because that axis of symmetry goes through the vertex. All right, the way you get that is by negative b over 2a, the vertex formula, negative b over 2a. All right, so to find the y-intercept, all right, when the way you find the y-intercepts, that's where it crosses your y-axis, right? So if wherever it crosses the y-axis, in this case, it's right here, 0, -2, you plug 0 in for x, and you find out what f of x is, right? Because if you're on the y-axis, you haven't gone right or left. That means your x value is 0. So you let x equal 0, all right? Basically, find f of 0. Okay, so you plug 0 in, and you find out what the output is. You find out how far you need to go up or down when you don't go to the left or the right. So examples of parabolas as 2, 1, or no x-intercepts. So you could have something like this. It's above the x-axis, so it doesn't have any x-intercepts. You could have something like this where it just touches, and then you only have one x-intercept. Or you could have something like this, where it goes below the x-axis, and then you have two x-intercepts. Okay, so those are the three possibilities. It just depends on how far it's been moved up or down. So find x-intercepts by solving f equals 0. Okay, domain and range. The domain is the numbers you can plug in where you actually get a number back. All right. So parabolas, it's all real numbers. So remember, domain is input. All right. So since these parabolas, you look at them, like this thing is going to the right as it goes up. If we keep going up and up and up, it keeps going to the right, to the right, to the right. It will go forever to the right and forever to the left. Right? If we're just talking about, if you look at the function, the form of the function, no matter what number I plug in for x, I could plug in the biggest number in the world. All I do is I square it, multiply it by a, multiply it by b, add those together, and I actually get a number back. Okay. So parabolas, it's the domain is any number you can plug in where you're actually going to get a number back. If you think about a different function like this, square root of x, you can't take the square root of a negative number, right? All right. So for the square root of x, the domain would be from 0 to infinity. Only positive numbers can you plug into this function. Because if you plug in a negative number, it chokes. Okay, because you can't take the square root of a negative number, not in this class. Okay, So this is an example of a function whose domain isn't every number, right? But this guy, it doesn't matter if it's negative or positive, you can square it, you can multiply it by a b, you can add a number to it, and you're still going to get a number back. So for these quadratics, the domain is all real numbers, which can also be written like this. All right. Or like this. All real numbers. All right, the range is the output. Okay. So if you look at these, all right, we have this minimum and the maximum, right? So for this one on the left, the range is everything above -2. Okay, so the range here would be -2 to infinity. Okay, because it goes down to -2, it goes up to infinity. So again, the range is the output, which is how far it goes up or down. Notice I put a square bracket here, not a round bracket. That's because this line, this graph actually goes down and it takes on the value -2. If I plug 0 in for x, I get a -2 back. So that square bracket means include -2. We put a round bracket by infinities because infinities aren't actually numbers. You never get to infinity. Okay. All right, so this one over here, the range, all the output values, the biggest it gets is 9. So we would, it goes down to -infinity, but it goes up to 9. So for the one on the right, the range is all the way down to -infinity and all the way up to 9. And notice where our range is coming from. It has to do with the vertex. The vertex is where the graph kind of ends, right? Okay, so the y value at your vertex is telling you what your maximum or your minimum is. See what I mean? And of course, it depends if it opens upwards or if it opens downward, right? For one that's opening upward, this y value at your vertex tells you the minimum. But if it's opening downward, the y value at the vertex tells you the maximum. So range, I'll just put right here, output or how far up or down. Page 102. Use the vertex and whether the graph opens up or down to determine the number of x-intercepts. Okay, so the vertex is -b/2a. This is going to give us the x value for the vertex. So here, what is our b? It's the number you're multiplying the x by. So the b is 5. We have a minus in front of it. A here is 1. This is 1x squared. We just don't write the 1 there because it would be stupid. So this is -5/2. Okay. Since A is 1, and that's positive, this thing opens upwards. Okay, so it's going to look like that. And we need to determine the number of x-intercepts. Okay, so what we're looking for here, I'll do that one later, is where the vertex is. You see, does this thing look like this, where we're above the x-axis, or is it touching the x-axis, or is it below the x-axis? Because then we would get 2 of these. So if we know where the vertex is, then we know how many x-intercepts we have. Okay, so the x value, x equals -b/2a, -5/2, that's going to tell us the x value of the vertex, which also tells you where that axis of symmetry is. So -5/2 is -2.5. All right. So that's where our vertex lies. It's somewhere on this line. All right. It's going to look either like this, or it's going to look like this, or it's going to look like this. But our vertex lies on that line. That's why we use the vertex formula. To see where it lies on that line, we have the x value. To find the y value, we just plug it into our function. So we got -5/2 squared plus 5/2 times 5 plus 4. I had to give us one of the sucky fractions. Okay. So let's see, we have 25/4 plus 25/2 plus 4. Okay, so if we turn in this into fourths, 25/2 is 50/4, and 4 would be 16/4. So we have 75, 85, 91/4. My calculator.
So like A is more certain.
No, A is equal to 1, which is greater than 0.
Oh, okay.
Yeah. See, our A is the number you're multiplying the x squared by. And you just want to know if it's positive or negative. If it's positive, it opens up. If your A value is negative, it opens downward. So I used the vertex formula. I found the x value. So right here at -5/2 is the axis of symmetry. I plugged that value into the function to see what the y value is of the vertex. It's at 22.75. So up here at 22.75, our vertex is way up there. Okay, so because our vertex is above the x-axis, there are no x-intercepts. So let's look at another example to make more sense of this. And I'm going to steal this so we can graph this guy. Okay. So our A here is 1, our B is -3, and our C is 10. Okay. A is positive, so therefore it opens upward. Remember, x squared looked like that, it opened upward. Negative x squared would look like this. Because anywhere you used to go up, you've made it negative, so now you go down. So this is what negative x squared would look like. It's just like x squared, but flipped upside down. All right, so this one, our vertex, x equals -b/2a. So we have a minus, b is -3, a is 1, so we get 3/2. So this tells us the x value for our vertex. It also gives us our axis of symmetry. If I go over to 3/2, that's 1.5. I know our axis lies on this line somewhere. This is x equals 3/2. Every point on that line has an x value of 3/2. Now, where the vertex lies on that line, we need to know the y value. We have the x value. If you have x, to find y, you plug it into your function, right? F of x is your y value. So we look at f of 3/2. So let's see, we got 3/2 squared minus 3 times 3/2 plus 10. So this is 9/4 minus 9/2 plus 10. So 9/2 is 18/4, and 10 would be 40/4. So we have 40 minus 9 would be 31/4. Stupid fractions. 31 divided by which is 7.75. So our vertex is on this axis here, but we have to go up to 7.75. So there's our vertex. It's at 3/2, 7.75. So that's how you find the vertex. Use the vertex formula, you get your x value, then you plug that x value into your function to get your y value. Boom. Since it opens upward, we know this guy looks like this. Roughly. We roughly know that's what it looks like. So now you can graph these. What we don't know here, what we haven't done, is we don't know exactly where this thing crosses the y-axis. All right. We don't know what that point is. We could find out. All we'd have to do is plug 0 into our function, because this line is where x is 0. We just find our y value by plugging that in. So if we plugged in 0 into our function, we get 0 squared minus 3 times 0 plus 10. We get 10. So that tells me this graph looks more like, move this up to 10. Looks more like this. Now that I know what the y-intercept is. And notice, since it's way up here, it never crosses the x-axis. There are no x-intercepts. No x-intercepts. Let's look at another example. Okay, so here A is -1, which is negative. So this thing opens downward. It's going to be something like that. Our B is 10 and our C is -25. So our vertex, the x value of our vertex, (b/2a). See, B is 10, A is -1. So minuses cancel, 10/2 is 5. So over here at x equals 5, there's our axis of symmetry. I know the vertex is on that line somewhere. To find out the y value, I just plug this in to my function to get the y value. So I got a -5 squared plus 10 times 5 minus 25. 5 squared is 25, and I get a 50. So this is 0. So that means, boom, right there. There's our vertex. It's at 5, 0. And this thing opens downward. So it looks like that. Let's do one stroke. Looks something like that. Now, whether it's like that, or it's like this, or it's like this, I don't know. We'd have to find where it crosses our y-axis to find out just exactly what it looks like. And we can do that. To find where it crosses here, everywhere on this line, x is 0. So we just we plug 0 in. We get -0 squared plus 10 times 0 minus 25. It's always the c value, right? If you plug 0 in, right, if you can always just look at your function and tell where your y-intercept is. Because if you plug 0 in for x, this goes away. It's the same thing with the y equals mx plus b thing. It's this constant left over is what you get when you make x 0. All right. So -25. So -25 would be way down there. So indeed, we know this thing looks something like that, as opposed to this. Okay. Okay. We'll just do one of these. Time. Do one of these at a time. Let's put that over here. And answer all their questions. So for graph A, the axis of symmetry is right here. That's at x equals 3. Okay. What is the vertex? It's this point right here. That is at 3, 4. All right, does this vertex give a maximum or a minimum? Well, it goes down to negative infinity, right? So there is no minimum, but the maximum value it takes on is up here at 4. All right, that's the highest it gets. The domain and the range, domain, all real numbers, because this thing does go infinitely far to the left and to the right, okay? The range, however, is the up and the down. It goes down to negative infinity and it goes all the way up to 4. All right, the maximum value. The y-intercept is right here, which is at 0, -5. Explain how 6, -5 is related to my answer. Okay, so this number, this right here where it crossed the y-axis, there's a mirror point. Remember, this is an axis of symmetry. That means everything that happens here happens over there. So this point right here is kind of like its mirror point. All right, so if you find out this point by plugging in x equals 0 and finding your y value, that gives you your y-intercept, you can easily, just by thinking, know what this point here is, right? It has the same -5 here, but you could see that we'd have to go to the right 6. So that gives you another point of reference to make your graph pretty, basically. So once you get this point, you know it looks something like this. Then you find this point, and then you know it looks just like this. And then you have the mirror point on the other side, which gives you the other side of it. Okay, so that's how. Echoes. So let's do another example, the same kind. All right, so the axis of symmetry here is right there at x equals -2. The vertex is this point right here. This is at -2, -5. Is it a maximum or a minimum? Well, there is no maximum. This thing goes all the way to infinity. But the minimum is down here at -5. Notice it's that same number that's in your vertex. Domain and range, domain, all real numbers. It goes forever right and left. The range, however, the lowest value it goes is -5. The highest it goes is all the way to infinity. The y-intercept is right here, which would be at 0, -1. Now, this -4, -1 is this point here. That's its little sister point. Okay. So let's take a break. Do a 10-minute break. We will resume at 11:53. All right, so, oops. So picking up where we left off, page 103. And do more of the same thing. So sketch the graph and identify the following characteristics. So our A here is 1. So that means this thing opens upwards. Our B is -6 and our C is 13. Let's open up. The axis of symmetry, -b over 2a. We have a -6 over 2 times 1. So 6 over 2 is 3. So we go over here to 3 and we go. That's our axis of symmetry. Our vertex is on that line. To find out where it is, we take this number and we plug it into our function. So we get 3 squared minus 6 times 3 plus 13, which is 9 minus 18 plus 13. So that would be 4. All right. So our vertex is at 3, 4. All right. 3, 4 input, output. So we go up to 4. So boom, there's our vertex. This thing opens upward, so it either looks like this, or it looks like this, or it looks like this, looks something like that. All right, to find out exactly what it looks like, well, because it opens up like this, it never crosses the x-axis, so the number of x-intercepts is none. Okay, but to see which version of this it is, we need to find out where it crosses the y-axis. So where it crosses the y-axis, wherever it is, that's where x is 0. So if we look at f of 0, we get 0 squared minus 6 times 0 plus 13. So it's not this, it's not this. We'd have to go up to 10, 11, 12, 13. So it looks like that. Domain, all real numbers. This thing goes forever right and left. The range, the smallest value it has is 4, and it goes all the way up to infinity. Now this guy, A is -1, which is negative, so this thing opens downward. Our B is -2, our C is -1. Axis of symmetry, -b over 2a. We have a -2 over 2 times a -1. Overall gives us a -1. So we go to the left 1. There's our axis of symmetry. To find out where our vertex is, it lies on that line. So let's plug in a -1. We got a -1 squared minus 2 times a -1 minus 1. So let's see. -1 squared is 1, but we have a minus in front of it. -2 times a -1. So this is 0. So our vertex is at -1, 0. So right here. Okay. And it opens downward, so it looks something like this, maybe like this. Either way, the number of x-intercepts, we only have 1 because it's just touching the x-axis here. All right, to find out what it really looks like, we need to find out where it crosses our y-axis. So if we plug 0 into our function, we got -0 squared minus 2 times 0 minus 1 minus 1. All right, when you plug 0 in, all you're left with is the C value, right? So go down 1, boom. So we know this thing looks like this. Because we know this point, we know its sister point or mirror point, which would be right here. So that's what it really looks like. The domain, it goes forever right and left, so all real numbers. The range, it goes down to -infinity, and the highest value it gets is 0 right here. It never goes up here. So that's your whole graph and all the properties of this parabola. So now you know how to graph any quadratic. Okay. And you do it enough, you eventually get to where you can just look at that and visualize it pretty easily, because it's the same steps every time. Let's look at another one. So A here is a -1, which is negative, so it opens downward. Axis of symmetry, negative B over 2A, -4 over 2 times a -1. 4 over 2 is 2. So we go over here to 2. Our vertex lies somewhere on our axis of symmetry. To find out where, we plug it into our function. We got a -2 squared plus 4 times 2 plus 3. So that's -4 plus 8 plus 3. What's 11 minus 4 is 7. So our vertex is at 2, 7. So we'd have to go up here to 7. There's our vertex. It opens downward, so it looks something like that. That tells us it's going to cross the x-axis twice. The domain goes forever right and left. The range, it goes down to -infinity. The highest value it gets going upwards is at 7. But to figure out what this thing really looks like, we kind of need to know where it crosses the y-axis. So if we plug 0 in, again, you plug 0 in, you're left with 3. Oh, they called this function g of x. I should call it g. So 3, boom, right there. So what we know is this thing really looks like this. And with this point, we know its mirror point would be over here. We could go a little further and we could find out where this thing actually crosses the x-axis. What are our x-intercepts? To find those points, right? Those points are when you haven't gone up or down, right? That's when g of x is 0. So to find those, we would have to take this and set that equal to 0 and find the x values. All right, we're not going to do that here, but that's how you would find these points. That's where y is 0, and then you find your x. Okay. So to find those, it's a later section. That's when we use the quadratic formula. When you have a quadratic equation, the quadratic formula tells you the solutions. Since you have an x squared, there's 2 solutions. Hence why there's 2 x-intercepts. So find x, and that tells you those. Okay, so here A is -3. It's negative, so it opens downward. Axis of symmetry, -b over 2a. We have a -30 over 2 times a -3. So 30 over 6 would be 5. So we go to the left 5. Here's our axis of symmetry. The vertex lies on there somewhere. To find out where, we plug that into our function. So we got -3 times a -5 squared minus 30 times a -5 minus 82. So we have, let's see, -5 squared is 25 times 3 is 75. We have plus 60 minus 82. So what is this number here? -15 minus 82. My calculator. I'm running low on my blood sugar now. 60 minus 82 minus 75. -97. Did I do something right here? -97 is a big number for a vertex. -3 times a -5 squared. Yeah, that's 25, yeah, that's right. Minus 30, so that's positive. Negative 97. Let me check this. Negative b over 2a, negative b is a negative 30, a is a negative 3. 3 minuses gives me, yeah, I guess so. So we'd have to go way, way, way down here at negative 97 to get our vertex, all right? And since it opens downward, it's something like that, which means it never crosses the x-axis. So we have 0 x-intercepts. To find the y-intercept, we just plug 0 into our function. Notice that makes that 0 and that 0. We get negative 82. So somewhere down here at negative 82, that can't be right. Our vertex is at negative 97, opens downward. Something's wrong, because this thing opens downward, it can't go up. That wouldn't make any sense. The y-intercept is at negative 82. That doesn't make sense because this thing would have to open upward. I did something wrong here. Let's try this again. Negative b over 2a. B is negative 30. A is negative 3. Minus a minus and a minus gives us a minus. 30 divided by 6 is 5, right? So now if I, to do that, I'm going to do it down here and make sure I'm doing it right. So if I plug in a negative 5, I get negative 3 times a negative 5 squared minus 30 times a negative 5 minus 82. Negative 5 squared is 25 times a negative 3 is a negative 75. This is it. 30 times 5 is not 60. It's 150. So there was my error. So 150 minus 75 minus 82 gives us negative 7. See, that's way better than negative 97. So instead of way down here, we're right here at negative 7. Our vertex is at minus 5, negative 7. Oh yeah. Now, this makes sense. Negative 82, we'd go way down here at negative 82. And that's where it crosses. Okay. So our domain, all real numbers, it goes forever right and left. The range, it goes down to negative infinity, but the highest it gets is here at negative 7. There we go. I don't know how I got 30 times 5 is 60. I guess I divided and then added a 0. Weird. Low blood sugar messes your mind up. So there's the homework. So whole lot of graphing quadratics. Let's go ahead and do this. Let's do our exam. Exam number 13. I'll go a few minutes early today. I'm hungry. All right, so we went to graph and label the functions. So let's do pick out number 2 here. Here's number one. And here's number two. Boom, both over here. Move this up. And a snapshot. Graph them both on here if you want to. Different colors. But anyhow, do what we just did, 10 times in a row. Fill in these for each of these functions and graph them. That's your exam for today, folks. Bye. All right, everybody out there in Zoom land got this? Bye, everybody.